Well, speaking of,
I was going to say we can actually be productive and get back to the matter at hand.
Yeah, let's talk about this, because we're talking about AI and really the whole. Well, I mean, I think the whole discussion served a purpose, because the purpose of the discussion is that AI isn't this big amorphous thing. It has to deal with a lot of data crunching, and the way to make LLMs work well requires large volumes of information that you can feed it that's relevant to the things you're going to ask it, right?
Yeah.
And in order to do that well, you need to have good data, or a very large comprehensive set of data, of both good and bad, depending on what you're going to say.
Hopefully good data in that large comprehensive.
Yeah, but the TLDRs, you need a lot of it, and you need to be able to go through it quickly. You need to be able to query, because that's what these engines are. They're super fast query engines that take natural language, and they're able to spit out answers based on like massive data sets. Like that's what's going on behind the scenes. It's not Skynet yet.
Yeah.
So that brings us to what Salesforce has been doing this year. And there's a new article that just came out, and I think Peyton might have that one up, but it's the data cloud will power AI analytics and automation using LLMs and business data across the Einstein platform. And so this was interesting to me because, and we're going to talk a little tech here, is because they're adding vector database capabilities to Data Cloud, and they're introducing this thing called Einstein Copilot Search. And so before we dive into the specifics of the article, Justin, since before Salesforce had any of this in Data Cloud or whatnot, you've worked with vector databases. We've done so with some customers. Why don't you give the high level view for the audience, what the heck a vector database is, why do we care, and we'll go from there.
Yeah, and I'll be honest, for the uninducted to truly understand it can be a bit of a dive into the deep end. But even if you just think about the name, right? Like anybody who knows what a vector is, even if like you've just messed with like SVG files, like you understand that a vector usually has a magnitude and a direction. And in this case, like a vector database is about implying directionality. So it's not, when you think about a normal SQL database, we talk about it in the context of like tables and rows. And so you're reading lists of data and you're querying, and you might have foreign keys that relate tables of data. But in a vector database, like the most important thing is the relationships between the data. So that idea of like a foreign key that, hey, this relates to this in this way, and there's a directionality of that relationship. And as you were talking about, like, how do you navigate a massive data set so quickly? And anybody who's seen like a visualization of a vector database, it's usually like several circular nodes, almost like a scatter plot, with then like arrows or edges connecting them, and potentially chaotic looking patterns. But what this is really doing is it's taking potentially large amounts of unstructured data and exploring and understanding relationships with them and the directions that those relationships should be traversed, so that something like an LLM based AI could be given a prompt and potentially have a tie-in to like a data point somewhere in that vector database. And then based on the structure of the vector database itself, know how to navigate through all these nodes in the vector database to build and infer relevant data.
So to break this down, Barney style for everyone. Let's talk a little bit about relational databases, what they are, and like have people seen it before? So like a basic relational database, like Justin mentioned, like SQL, or if you're in the Salesforce world, SQL is the query language they use. Objects or tables, related lists, or foreign key relationships. The way that SQL databases work is they organize everything into, you could argue, like glorified spreadsheets. You have a spreadsheet of data. You have
data typically, right? Because you're not just like throwing whatever you want in a list. It's like all of my accounts go in a list titled accounts, and I can't throw contacts in my account list. That's not how.
So it's a list of ordered. It's an ordered list of specific data tables, and a table is defined by a piece of what's called metadata, stands for describing data. Meta means about. So you might have an account table, and so that's the metadata about is what is this? What fields does it have? Oh, so an account has a name, it has an address, whatnot. So that's all things that are describing this table of data that you're going to have, like this Excel sheet, right? And so that's what SQL databases essentially are. Like, there's obviously complexities with how they index and other things, but effectively they're ordered lists of specific data that you're looking to track, and then there's different types, and then your entire database has a bunch of different these order lists, and they're related to each other based on that metadata. So you might have, hey, this one has contact IDs, or you do join tables and whatnot, but the relationship, although is supported in SQL in these traditional databases that most everyone who's listening to this or will listen to this is used, whether it's Salesforce is a CRM, because it's all effectively SQL-based, all related database. The relationship's an afterthought. You could build very complex relationships. You could query through them quickly by using proper indexing and whatnot, but the relationship is not the point of the database. The point of the database is just to be a storage of organized, ordered data. And this is just like, I'm hyper simplifying a lot of this stuff, but that's where the problem comes in, is when you not have even thousands of rows or tens of thousands or even 100,000 rows these days. It's when you start getting millions and billions and trillions of rows of individual data and trying to organize it using a relational database like SQL is just exceptionally inefficient when you're trying to traverse it. It's very useful for specific things, to do specific actions. It's super easy to input, output data. Like, it's very good at that. But to search large volumes of it, it's a pain in the butt. And anyone who's used Salesforce, who's familiar with the limits that they have as a developer, your query limits of 50,000 rows, and them using skinny tables and big objects and whatnot to try to get commonly queried or commonly used objects.
You remember the crazy SQL queries I used to write as a developer to navigate parent-child relationships, and I'm actually going to run this query at the junction object level so I can jump up both paths and do this, that, and this other thing. And then I'm, doing nested SQL queries inside to grab child properties. There's limits on how many relationships, and it's not something you'll find necessarily in a document, but you can't have a nested SQL and a nested SQL and a nested SQL and a nested SQL. So the technology, the way it's designed, the way it's structured, there is a hard upper limit on how many relationships you can navigate between data.
So when you look at your developer, you're like, hey, I need to pull out, I need to make this report. It's got to be custom. I need a lightning component, blah, blah, blah. And just what he said, where it's you can't do nested SQL, nested SQL, right? In order to get this data. So what they're doing is they're bringing a bunch of lists together, and they're iterating through all that data and recombining into a new list or a new map in order to present back to you.
Well, and I want to touch on something what you said there, right? So it's not even that they care about the entire list, right? Because if you're running a report on a single account, you have to look at the account list to get the one row you care about, and then run the subsets of all the other lists for the child data, so on and so forth. And I think that's part of how this technology arose, right?
Well, that's what I was getting to, is that you're gathering. So you could do some filters and whatnot, but at the end of the day, as you try to go through this, you have to add your own manual filtering. And the problem is that it's like casting your hand into a pond in search for a fish. And it's if you do that with just your hand, the chance of you grabbing the thing you want is zero. So the way that developers do it, you could do it really efficiently, is you get a giant net, and then you grab everything, and then you're all right, let me sort through this and throw out the stuff I don't want. And with all the stuff that you talked about and the only way the different algorithms and searching logic you can use, you just get better and better nets. But for the most part, you're pulling in a whole bunch of stuff you don't need.
I mean, that's basically what your index is, right? Is you're hey, I need 5 things on an index the first thing I need on that index is this thing. The last thing I need on the index is this thing. And it basically grabs everything from beginning to end. And then it's like, what else, what's in here that I don't need? Okay, get rid of all of that. And for those of you who've worked with Salesforce selectivity limits, this is exactly what we're talking about right now.
Yeah. So that, again, it's great for what it is, but for what it's not great. So Justin, now that I've used a fishing analogy and whatnot, let's talk about vector in a non-technical sense. Why, like when you make relationships the priority and you let the data be unstructured, which is really difficult. It's not very easy to be human actionable because it's unstructured. Why is that better? And why do we care that Salesforce is doing it now for Data Cloud?
So, and I've actually spent a lot of time thinking about this because I'm a nerd and that's what I do. I can kind of imagine exactly why technology evolved the way it did. Because if a relational database is designed for storage, let's say, right? As you said, and I want to build to this for a second. So let me set the table, if you will. If they don't like it, they're going to cut me out, guys. So don't worry. The relational database, to me, that's how a human being would think about organizing their life or a massive pile of stuff. It's like, I'm going to categorize and I'm going to put like stuff with like stuff in boxes. And that's how I clarify my thoughts. That's how I clean up my room. That's how I sort. Then we got into the idea of like, I'm going to not jump straight to vector databases. Let's talk about NoSQL databases, which at the end of the day is basically just a file that you could then write object structures into. So like, let's say we're using like a JSON style notation. So,
okay, so you less technical.
Fair. So the idea is in a NoSQL database, you're not implying necessarily like strict table structures where a list is like, these are the columns that are present on the list. And so everything in this list can only have values for things that we have columns for. In like a NoSQL database, you're like writing something to a file. So if anybody's ever looked at like a JSON object and can imagine like, oh yeah, you know, I can imagine this syntax of key value pairs, and there's nothing on the file that tells you whether or not the key value pairs for a single record are valid. Like you just have every key value pair you want, and a value could be a sub object with more key value pairs. And so it's very loosely defined. And I think part of the reason that arose was people realized like relational SQL databases are great for storage and organizing and imposing order on your data. But when you're building something and you don't know exactly what your data is going to look like yet, and maybe it's evolving, maybe you want to be loose and more flexible with it, the requirements that are imposed by like, hey, you can only have values for things you have columns for. And if you want to have a value, you need to add a column, and that's added to every row in the table. It's got some limitations. And this is why like boot camps, like when they're training developers, they go NoSQL, because it's like you can figure out your data model as you go. Like, oh no, I forgot a property. You just add it. You add it and you save it and it works. And that's it. You're done. It's fine. So then to take that even a step farther, it's like, well, you know, do we even care about the structure of like a high level object or how this thing is? Because like when you think about like early, like let's talk about like GraphQL or other vector style databases, right? You can break up what might be seen as a single record in a relational SQL database or a NoSQL database into actual several nodes and vectors tying them together. And the idea is that when you're building automation, when you're trying to build a function or a feature set, do you really care about the comprehensive shape of the data or imposing order on it? Or do you just care about understanding how each piece of the data relates to all the other pieces of the data? And it really is this idea that, you know, you drop a pinpoint somewhere in a vector database and you started a node, and then from there, you know all the places you navigate to and how they relate, because the nodes will have qualitative descriptions as to like, this is what the values about this particular piece of data is, what that means. And you can use some of the metadata around that node to help, you know, ensure uniform processing, where normally you'd say an account is an account is account. I know how to handle it. You're like, this node is this kind of piece of data. I know what I'm doing. And here's other data it's related to. And here's what that relationship is. And so the idea is you let go of the tedium and the restriction of imposed higher level order on the data to just say, I need to be able to easily navigate through it to get from one point to another point, having it describe to me what these paths are so that I can execute a process or a job. And when you think about like a single execution context for like a piece of automation or something, like, does a computer, does a process really need to care that something's an account or whatever? If it just needs to do something to data and you can accurately convey how to navigate through the data and the database supports it, why not strip it down to just that? Why not open yourself up to that? Because these nodes and these vectors are so much lighter weight than a table and a row. And so the ability to have a largely amorphous network of these that mesh together that a process could then navigate through, that really changes the way you think about how you interact with your data. And
so I think Justin completely failed to break that down into a non-technical level, or even have a good analogy to like.
Oh yeah.
But no,
but you asked the tech guy to get non-technical, so I got to stand up for myself a little bit. I tried.
Yeah, no, I think the way to think about it, it's like if you were looking at trying to, like, what's a really good, because it's definitely something that's hard to really pin down for someone who isn't fully tech savvy.
Let me see if I could really tell me if this works.
Well, no. So here's my
databases care about records more than they care about tables, right? So when you're interacting with a relational database, you're trying to find your record in your table and then find the related records to that record in other tables to get whatever kind of data you want to run a process. With a vector database, you don't care about this, like describing what your starting data is, where you're beginning from in the database. You're just saying like, hey, here's your starting point. Like, I'm giving you a node that I want you to begin from. I'm informing your process there, and then you can see the relationships and navigate them, because again, you don't care about all the other records in the table. You only care about the stuff that's related to the specific thing you want to begin from to do a job. And so you step away from this idea of sorting through lists to find what you need to say, why do we even have a list? Like, why can't I just say it's that thing right there? Like, point at it, start from there, and then navigate your relationships. And then you're pulling in the extra information. And that's how LLMs are able to basically cover massive amounts of data efficiently, is because the data doesn't have to be hyper organized and rigidly structured or whatever. It's basically reading the words that you're giving it on the input, and it's using that to find a starting point in a vector
anyway,
and then run.
I still don't think you did a good job to explain it. But I think we got to
do my best.
Yeah, like I was going to talk about like an airport terminal type of a thing.
I'm
looking at the. Anyway, I think we got to move on. But like, let's talk about what Salesforce has done here. So Salesforce has added vector databases. We've kind of talked about like the TLDR, since we haven't really gotten into a good analogy for the reason why vectors are good, but being able to focus on the relationships rather than focusing on the structure of the data allows you to go through it much quicker. So the fact that Data Cloud is allowed to be modified into this unstructured fashion allows you to port data into LLMs more efficiently, or allows LLMs to leverage it as part of their data sets. So this is fantastic. But what's the, what is Salesforce doing better here? And it's specifically with the Einstein Copilot search, which isn't out yet. They're saying it's out in February.
Yeah.
But let's talk about specifically like 5 minutes about this, and then we'll kind of go on from here.
Sure. So first, if you don't mind, I want to talk about why they did it, right? And I think
we know why they did it.
Well, because they want to get all your data in data cloud, right? Across all your orgs, all your Salesforce product, all your other systems. And so if that's the place they're going to keep the data, they're building a rather large data set there. And so setting up vector database functionality in data cloud so that that data can be effectively navigated and used. I think that what they're effectively trying to do here is what we've talked about for LLM and vector databases, this idea of how could Einstein AI make use of all of this data that you've pumped into data cloud and navigate it efficiently to give you these insights based on stuff that's, you know, not just native in your Salesforce org, because Einstein does that pretty well, I would say, but data points from other orgs, from other systems that you've brought in. How can it be like, oh, hey, also, I noticed that for this opportunity you're talking about, there's a fulfillment issue that came up with this customer that hasn't been reported to you yet, but it's in your ERP and you sent this data in the data cloud. I can navigate this, understand the relationship, see that this is relevant to what you're trying to do, so I can bring it up and tell you about it.
Yeah, so I think the big thing here is that they're allowing this flexibility so that they, like again, you said, they want all the data. So they want you to be able to throw in PDFs so that it can take a look at that email, social media posts, and make this accessible through other searches or application usages in your CRM or throughout your business, like using Data Cloud. Yep. They want to make it all this type, voice recordings, meeting recordings, all this stuff. It's like, give it to me all. I don't care what it is. I'm just going to relate it to things based on context. Like that's the goal. It's like, hey, this is related to this account. This is related to here. And when you start talking about integrating multiple disparate systems, one of the biggest challenges that we have here at RadialSpark when we work with a lot of customers who have like legacy systems, new systems they're trying to incorporate is building the understanding between one relational database and the other of like, hey, what's this transaction going to look like? What fields do I expect? What fields do I absolutely need to have? What tables need to exist? What do these relationships look like? All this other stuff. And you have to build an entire translation layer in order for system A to understand what system B is. And so that people in system A and people in system B could do their jobs, right? The cool thing with Data Cloud is it's like, listen, we're just trying to get a handle on your data so we could run insights, so we can market better, so we can make recommendations, so we can have AI leverage this to do things like we talked about in our last podcast when we were talking about like the Service Cloud outage usage, right? And one of the big hurdles to doing that with, again, when we talked about earlier in this podcast with big data is like, oh, I just got to structure all this and set up this, like that is a huge pain in the butt. It takes a lot of time. And so that the fact that they're allowing us to start dumping in unstructured vector data, again, it won't be imminently useful for a process right away, but the fact that they allow that really cuts down on a lot of steps that that you often have with integrating with other systems. And since we're talking about that,